Hi, welcome to Chapter 1. You might find it interesting to note the title for Chapter 1, which is Introduction to Digital Geography. The reason for this term is that GIS is in fact a digital version of everything we've learned in geography over the past 2,500 years. And basically it's been encoded inside the computer at this point and now constitutes what we know of as GIS software. As with most courses, we'll begin with definitions. And so what we need to do is to define exactly what Geographic Information Systems stands for. Typically, one thinks of fairly narrow definitions of GIS, and it depends pretty much on your perspective. You find, for example, that database types think of a GIS as a database. Software types think of it as a piece of software. We're going to define it in a much broader context. We'll begin by thinking of GIS by looking at the S first, the system part. GIS is, at first, a system. And like any system, it is composed of multiple parts. And so what I'd like you to do is when you think of geographic information systems, I'd like you to think about it in terms of the other kinds of systems with which you might be familiar. You might, for example, think of a solar system comprised of all the various planets, the sun itself, and the other subplanetary bodies that are circling around the sun. That's one type of system. You might think of a system like the cardiovascular system pictured here, which shows the heart and all the various valves and tubes that move blood through the body, the veins and the arteries, etc. Again, all the various components of a single system. Those of you who tend toward the physical geography end of things might think about a storm system. Here we see a storm system with various components, the clouds and the wind and probably rain and even hail and what have you. Again, a system composed of many parts all integrated together, all making it act as a single unit. For the rocket scientists in the class, you might think of another system like a propulsion system with all the various components that make a rocket fly. Again, all these components working together as a single whole. And for the computer scientists in the group, you might think about an operating system as a type of system. Here you have Linux, for example, Windows, or the Mac OS operating system. All of these systems, including this one, are composed of many parts, all of which are integrated to work as a single whole. Perhaps you can think of one or more additional systems that you are aware of, and if so, please feel free to comment and add them to our list here. Now that we've considered GIS as a system, a larger system with multiple components, let's take a look at what some of these components are. Starting at the top left, they are the software, and this is the component that many people think of first when they use the term GIS. So it is important that we have software, but of course without hardware, and that's the second item that listed here, the software has nothing on which to run. On the bottom left we have data. You need data for the software. The GIS doesn't operate in a vacuum. It does need hardware and it needs data. The data frequently come from vendors, which is the bottom category, bottom center. And vendors provide more than just data. They may provide the software itself, they may provide hardware or other kinds of services. Moving up from there, we have institutions. Institutions are basically the organizations within which GIS resides. For example, you might have GIS operating as a piece of class software, as we do here, in which case you get free versions of the software. Well, you don't get those free versions in other kinds of institutions. The Central Intelligence Agency has their own use of geographic information systems, and they are, of course, quite secretive. Criminal justice types of operations require different symbol sets and different kinds of tools, so they have different needs. So each institution basically places different needs and different requirements on the software itself, not only on the software but on how it's going to be put together and what have you. You also need clients, somebody who's going to purchase the results of your work. Now there are many other components in here. For example, the users themselves, the people doing the GIS operations. The GIS analysts would be part of the system, if you think about it. Even the money involved in operating the entire system. It could even include things like the network that requires different kinds of systems to move information from one place to another. So you can get data, for example. You may have a distributed system where you have a central office and multiple offices, kind of branch offices all over the place, and they need to operate the GIS as well. And so this is all part of a very complex network of components that makes up what geographic information systems really is and what it stands for. Before we leave this topic, you should be aware that GIS is actually acquiring a new term. It's pretty much been adopted, in fact, in academic circles, in that GIS has now been expanded to be GIS and T, which means Geographic Information Science and Technology. You'll notice I paused when I used the word science, because what they're doing is literally studying the various parts of geography that make up the kind of theoretical foundations for the algorithms that are included inside the software package and that are employed for analysis. So the discipline is changing. But this gives you some general idea of how GIS operates as a system. As you begin learning geographic information systems, and in fact geographic information science, which is part of what you're going to be learning, you will encounter a number of people along the way who, when you say geographic information system, they will tell you, oh yes, I have one of those, and they'll pull out their cell phone or they'll pull out a small pocket GPS unit. In other words, they will frequently misinterpret the term GIS and think of it as GPS. The whole idea, though, is that GIS is actually coming closer to home. And in the next couple of slides, I'm going to show you a couple of quick examples that you can use to illustrate to your man on the street that GIS is not GPS, but that, in fact, they do use it. One quick example of a very rudimentary form of GIS would be something like Yahoo Maps and similar types of products, where you can go online and literally give a starting point and an ending point, and the software will use what is known as a shortest path algorithm, and it will direct you from one place to another. Not only does it produce a map as an output, it also produces a road log, literally telling you where you're going to go. It's kind of a route that you can follow, and it literally puts it down as text. Now, this is part of what you will find inside of full-blown GIS. So if you think about it, Yahoo Maps is not really a full-blown GIS, but it does use some of the GIS capabilities. So I like to refer to it as a rudimentary GIS. Given that I mentioned GPS in a previous slide, it turns out that GPS, of course, is part of an integrated system in many cases. This slide, for example, is showing the inner workings and hidden mechanisms of a system you may have heard of called OnStar, which links telephone conversations and emergency personnel through GPS and through telecommunications. So in a manner of speaking, this is again a rudimentary part of GIS. It's not a full-blown GIS, it's just rudimentary, but it is a component that you will find in many full-blown GIS systems. For example, in 911 systems, they may have some of these capabilities built in. Likely most of you have seen this thing. You know it as Google Earth and hopefully have used it. Google Earth, believe it or not, thinks that they are a GIS. They have some of the capabilities of GIS. You can, for example, with the professional version, upload real data, which is really nice. You can get three-dimensional viewing. You can do fly-throughs. It gives you latitude and longitude. It allows you to calculate distances, even path distances. And with the professional version, you can also measure areas and things like that. Google Earth actually has the look and feel of a real GIS. Its major issue is that it's highly limited in its capabilities. So once again, you're looking at a rudimentary geographic information system, but it's a good place to start. It really is. For those who are not willing to dive headlong into the ArcGIS learning cliff, this is something that the casual user can find useful and in fact get some real analytical results out of. But again, it's still a rudimentary version of GIS. GIS is much more complex than this. Earlier in this lecture, you heard, especially when we were talking about the definitions of GIS, that the whole terminology is beginning to change and that geographic information systems is becoming geographic information science. Well, whether it's basic algorithms or conceptual ideas, all of GIS is based on geography. In fact, it is based primarily on the history of geographic inquiry. And so for the next 4 slides, I'm going to talk to you about the 4 basic categories, the 4 basic steps, and they are steps indeed, in the geographic inquiry process. And these will serve you well throughout your career in GI science. The first step in geographic inquiry is much like the first step in the scientific method. It involves observation. Here you have an artist's conception of Lewis and Clark on their trip across the United States, looking at the Louisiana Purchase. And what they first did was to observe what was going on across the landscape. So this is the first step in geographic information science as well, is to observe, to make observations about the kinds of data sets that you might need to use for a particular problem and what have you. So it's the very first step in the geographic inquiry process and the very first step that you will encounter in geographic information science and GIS. Observation, of course, is not enough without some sort of documentation or description. Description, then, is the second step in geographic inquiry. Most geographers use the map as the primary tool to describe what they're doing. Lewis and Clark, of course, did have sketch maps. You can actually search for some of them online, see some of that stuff. But they also kept extensive journals. Journals are also part of the documentation and are also part of what we see in some forms of GIS. You will, for example, in some industries, such as the real estate industry, you'll have pictures of houses and photographs of the insides and even videos as part of the documentation and part of what you will actually include inside the geographic information system. So again, the very first step in geographic inquiry is observation. The second one is description. The third step in geographic inquiry is explanation. If we observe something, we then describe it and document it. The next step is to try to figure out what the pattern is. If we can observe patterns, what are the patterns? Why are they there? What are the reasons behind particular things that we see? Here, for example, is a picture from October 14th, 1962, and it is photographs taken from U-2 aircraft. U-2 aircraft, of course, were used during the 1960s, spy aircraft. And these are pictures of Cuba, and they are showing individual pieces of information and content that were presented to President Kennedy to explain to him that there were missiles being placed in Cuba. And so the whole process of explanation is critical to GIS. So one of the things that you will be doing throughout your career in geographic information systems and geographic information science is using this tool to not only describe what's going on, but also to explain what the patterns are, why they're there, and what the possible consequences could be. Now, if you are able to describe patterns and to explain those patterns, you have some idea of what the mechanisms are behind the patterns. That gives you some serious power. In this particular case, it gives you the power to predict future patterns. In this slide, we see New Orleans, and it was literally a prediction of where the floods would occur. This, by the way, was created about 4 months before the storm ever happened. So, you can predict traffic patterns by looking at existing patterns of growth and where the traffic is already bottlenecked. You can predict troop movements based on where things have already happened in the past and the kinds of terrains that you see and the patterns that are there. There are many, many types of patterns that we can observe. As geographers, one of the things that we need to do is to sensitize ourselves not only to the patterns, the ability to see patterns and to recognize them, in other words, to be able to observe. We also need to be able to figure out how to document this properly through mapping, how to explain these things through the power of the analysis inside the GIS, and even to use this to build predictive models for the future. These are the strengths, these are the tools of the GIS professional. These are the things that are going to get you a good career in the future. So, take care to note these 4 steps and to memorize them because you will be using them throughout your career. While most students assume that GIS sort of started the day they took their first GIS class, it's actually been around since the early 1960s with the development of the Canada Geographic Information System by Roger Tomlinson. The next couple of slides actually contain movies. Take a look at the slides and follow the directions, and they will actually direct you to watch a couple of movies related to the history of GIS. This is just a picture of an actual movie that I produced. The movie is on the original PowerPoint slides, although they have a tendency to get stripped when I upload them to Canvas. I believe the movie is also available as a file download from within Canvas and as an activity within your soft chalk exercises. What I'd like you to do at this point is to go and take some time off, stop the lecture here, go and observe that movie, and then come back after you've seen it and ask some questions. Literally pose some questions on this slide, on this frame, about what I was trying to say in that movie. There are some sort of hidden messages there for you to learn. So take some time to review the movie and enjoy the music that goes with it, and come back and make some comments here on this frame. I found this on YouTube. It was actually in 3 separate pieces, and I managed to use my software to piece it all together as a single movie. And this is a movie that was produced by the Forestry Department in Canada, and you will actually see the father of GIS, Roger Tomlinson, and he'll be talking about the CGIS, the Canada Geographic Information System. This was the very first GIS ever to be produced. There were academic software packages being played around with at various universities, including Harvard, but the very first operational GIS was the Canada GIS, produced by the father of GIS, Roger Tomlinson, whom you saw a picture of in the previous movie. So again, take some time out, stop this voice thread at this point, and go and take a look at the movie. Again, I've stored it on Canvas and in your soft chalk exercises, and may even manage to get it up on VoiceThread here. We'll see what happens. But take some time out to watch this movie, and it will give you a real nice perspective of the thinking behind the first GIS, and in fact the thinking behind what we think of as GIS today. One interesting anecdote illustrated by this slide refers back to that first movie where I show the first computer used in the early development of the Canada Geographic Information System. It showed the computer with a very limited memory, and the memory is based on kilobytes, and most people today think in terms of gigabytes or even terabytes. We have terabyte-sized hard drives commercially available for $100 or less. And so thinking in terms of size is really difficult to give you an idea of the kinds of challenges that were faced by the people at the Canada GIS in the beginning of their system. So if you take a look at this slide, you'll notice that all I have done is created a single Word document with 2 letters that say hi, and it is already at 24 kilobytes, which is far bigger than the entire core memory of the first computer used to build a GIS. So you can imagine some of the challenges that they had to face back in the 1960s. As you may recall, we talked about GIS as being a system made up of various components. One of those components is the software itself. It turns out that the software, as a subsystem, if you will, of GIS, also has various components. Usually we think of these as 4 subsystems. These 4 subsystems were first defined by Dwayne Marble, who's now retired from the Ohio State University, and with whom I was fortunate enough to work for about 6 years. So in the next slide we'll take a look at the 4 subsystems and give you some definitions. Here you see a Venn diagram showing the 4 subsystems of GIS all coming together in one central part. So the GIS software is a subsystem of the larger GIS, the larger context with which we've been talking. And within that we have 4 subsystems as well. The first one is the input subsystem. This includes any of a number of different ways of getting data into the GIS software package. This includes anything from photographs, scans, satellite imagery, GPS data collection, manual digitizing, and input from existing databases. The next subsystem is the storage and editing subsystem. It doesn't do us any good to have data going into the system if we can't save it, can't store it. And of course we need to edit it as well to make sure that it's a clean data set. And we will be tapping into this thing frequently when we do both analysis and just data entry. The third one on the bottom left is the manipulation and analysis subsystem, and this includes everything from just manipulating coordinate systems to doing serious analysis and serious modeling. And we'll take a look at some of these capabilities later on. And of course the output subsystem. The output subsystem is frequently misinterpreted as being the mapping system. In fact, there are many types of output from GIS. You recall, for example, when we looked at the Yahoo Maps description, one of the things it had was a route log indicating a path that you could travel for shortest distance from one place to another. This is one form of output. You can also get graphic output, tables, charts, diagrams. You can have fly-throughs, literally three-dimensional animated movies showing a fly-through of a terrain. You can even have telephone calls sent to a 911 center. So there are many, many different ways of getting output from a GIS. So the output subsystem, although often underappreciated, I guess, is very, very powerful. So in terms of analytics, what are the things that a GIS is capable of doing? In the next few frames, I will be describing just briefly some of them. You'll learn a lot more about them as the semester progresses, but this will give you a first impression. Although often not recognized as part of the analytical tool set, one of the things that GIS is capable of doing is to organize and reference your data. It might surprise people to realize that one of the things that is used most often in GIS is simply retrieving the data sets that have already been put in after they've been cleaned up. It allows people to get access to them whenever they want. So it basically acts as an archive. But you can also do all kinds of work with changing map projections, changing datums, and the whole bit. There are many, many ways that we can use these tools to change the way the data set appears as a cartographic document, and to compare and contrast different kinds of maps at different scales and at different projections and what have you. So these basic tasks are really critical, although they are often unrecognized. I'll give you a minute to stop chuckling after looking at this picture, but in fact querying and doing solid analysis and aggregating data in particular are some of the more important and some of the more critical tasks that you'll use inside GIS besides just storing and retrieving. And here of course we have Spock, who is basically querying Dr. McCoy for information. This is the evil Spock, in case you have forgotten, or for those of you who have never seen him in the first place. But to be able to query the database, to be able to ask questions of the database is incredibly powerful. In fact, it's probably one of the single most used types of commands within the GIS. It's not a single command, it's actually a series of commands based on the graphical user interface. But the idea is that frequently what people want to know is already in the database. They don't need to do much in terms of analysis. Once they've acquired the data, they will frequently have to aggregate them, group data into meaningful clusters so that they can understand stuff. And these are two of the most powerful tasks available within GIS, although they are, they don't require a lot of sophistication on the part of the GIS software package. Here we have Count Von Count, for those of you who recall the Sesame Street character. What Count Von Count did was count things, and in fact, this is again one of the more useful tools of the Geographic Information System. It allows us to count up the number of points, the number of polygons, the number of lines that are contained in a database. It allows us to give the users some idea of how complex a database is, and in fact eventually we can figure out where things are and what have you, because they're all registered to a geographic grid. Classification in geography is far more important than people give it credit for. The GIS is capable of classifying and indeed reclassifying pretty much any kind of map that we have. This is part of the aggregation algorithms in some cases, but in others it's simply a matter of selecting what categories we want to call what names. Now, the thing about classification is that once you impose a classification on a map, you limit the capabilities for analysis later on. So classification is really, really critical, and it's unfortunately understudied inside GIS. In fact, I'm currently writing a paper about that. Hopefully you will be able to see that. It should be published in the International Journal of Applied Geospatial Research. So you can look for that. Among the very first analytical capabilities considered for the Canada GIS was its ability to overlay maps. One of the things we've discovered through the some 2,500 years of geography is that there are many, many patterns that tend to co-occur. In other words, they exist in the same geographic space. This allows us to begin to analyze patterns not only for juxtaposition but also for causation, because, for example, various types of vegetation may occur as a direct result of the kinds of soil or the kinds of topography upon which they reside. So one of the most powerful tools in GIS is its ability to do map overlay. We can do map overlay in a number of different ways, and we'll discuss these in some detail as the course progresses. The software you'll be using in lab contains a module called Spatial Analyst, and Spatial Analyst is designed specifically for creating very complex GIS models using this sort of flow charting tool that you see here on the screen. Modeling is really extremely sexy, and there are some really exciting things you can do with it. The problem is that most of the organizations that use GIS are not well aware of the potential capabilities of GIS, and those of you who become GIS analysts, some of you will become very, very frustrated in your positions because you won't actually be able to do the kind of modeling that you want to do. Still, knowing the capabilities that are there is important, especially if you plan on becoming a GIS designer in the business environment, so you can actually teach people the capabilities of the system so that they can start using it. As we get more and more people who are familiar with this and who are able to impart that information to the people who purchase the GIS software, the more complex modeling there will be, and in fact the further the science will be pushed, because people who use this stuff will be discovering very early on the limitations of the existing models based on our current knowledge of geography. There are some misconceptions about computer-aided design and drafting, computer-assisted cartography, and GIS. We'll examine these in the next couple of slides. Although it appears on the surface to look very much like Geographic Information System, the computer-aided drafting and computer-aided design software is actually not designed for mapping. It's designed primarily for creating plans. As such, it isn't readily set up to deal with geographic coordinate systems, although this, of course, is changing through time, and in fact, CAD is becoming more like GIS, and in some cases, GIS is becoming more like CAD. But the key with this is that in traditional CAD systems, if you overlaid two different layers, you could visualize them, but you couldn't actually save that as a third layer. And that separates it from GIS. When you do map overlays in GIS, its final product is a third layer that contains components of both of the originals. So there is a difference between computer-aided design, computer-aided drafting, and GIS. Computer-assisted cartography does indeed allow one to work with geographic coordinate systems. It's primarily designed just to create a single map. It's not really designed for analysis. And so the computer-assisted cartographic system essentially is a linear system. You input data, you put the stuff in and store it inside the computer, you then edit it and output a single map. As you will see in the next slide, this is not the case with GIS. This flowchart illustrates the cyclical nature of GIS modeling as opposed to the linear nature of computer-assisted mapping. You'll notice, for example, that you can encode a number of different layers. The text on the bottom of this diagram clearly indicates what's happening here. We're adding this map, that's the name of the map in the lime green up there on the upper right hand corner, to that map, which is right below it in the olive green, to create a new map called New Map, which is then stored back into the database. It's not the final output. In fact, these are called interim maps because they're part of a larger analytical process. The idea is that you do bits and pieces or parts of a model, put them together, and then take those components and combine them to make a larger model. So this clearly indicates that GIS is a secular process as opposed to a linear process that you would find in computer-aided design and or computer-assisted mapping. We'll close out this lecture with just a few examples of the kinds of things that can be done with GIS. In other words, some of the industries that can be involved. This is a picture of Baghdad after some explosions took place. The satellite imagery that you see was used extensively in 1991 in various battles and what have you. And in fact, this intrigued the people in Washington so much that they decided to change the name of the National Imagery and Mapping Agency to the National Geospatial Intelligence Agency, all based on the GIS activities that were being used concurrently with the war itself, the war effort. One of the more exotic uses of GIS included the use of LiDAR data, which is laser data. You can see here a LiDAR image that shows what's left of the Twin Towers in New York City after the two airplanes were flown into them. It turns out that within hours after that attack, the City University of New York's Geography Department began putting together a fairly extensive GIS database to help direct traffic around this crash site and to also help the 9/11 people do their job. Very cool stuff. The Centers for Disease Control is actually a major user of GIS technology. Here you see a map that they produced dealing with avian flu across the globe. As you might expect, this is also taking place this year as they examine the movement of the influenza virus, rather nasty one, across the United States. As you might guess, the list of potential users and the list of potential applications for GIS is quite extensive. In fact, it would take me a month of Sundays to try to explain even half of them. One way to get a handle on what's available and who might be using GIS is go to the esri.com website. That's esri.com. And included in that website on the very beginning is a category up in the top. You'll notice here it says right next to home, it says industries. And when you click on that, this screen comes up and it shows you all the various industries that are out there. I would advise you to take some time to go to this site, to wander around, to click on these links, and to get a handle on what GIS can do and who might be using it. Not only is this enlightening, but it also gives you some clue as to the possible positions that you might obtain for employment once you finish your schooling here at New Mexico State University. Thanks for attending these lectures. Please feel free to comment on any of these slides. If you've gone all the way through and you haven't done any commenting, feel free to go back. You can visit any slide anytime you want. See you next chapter. Bye.